All right, on to Unit 4, doing transformations this unit. So first up is translations. We did some of this in Algebra 1 last year. You saw it in pre-algebra classes, so it should not be completely brand new to you. So a transformation is just a function that moves or changes a figure in some way to make a new figure they call an image. So your original one's called the pre-image. So your pre-image points, that's your inputs, and the points the image are the outputs. So translations, you should recall from previous classes, it moves every point of your figure the same distance in the same directions. It could be left, it could be right, it could be up, it could be down. It could be left and up or right and down. It can go diagonal, but it's going to go the same direction. So you have the exact same figure, just in a new place. With translations, there's no spinning, there's no flipping. They're sometimes called slides because it's just like sliding an object on your desk. You grab your textbook and you just push it to the right without spinning it at all. That's a translation. So basically, you get like parallel segments. They can just move. You use what's called prime notation. That's a little asterisk. So like this right here is P prime. So this will be read as segment P prime Q prime. And it does matter because without the prime marking, that means it's the original point. So translations, we use rules. And the rules are written just like this every time. They're very straightforward. The first part is just specifying point XY will become, the arrow means will become. And then you have your rule for X and Y. Does A have as plus A, could be minus, who knows, and plus B. And all it means is do that operation to the rule. So if we want to move triangle PQR to triangle P prime Q prime R prime, and yes, that's how you say it, we got to figure out first what happens. So pick one of the points. P is fine, doesn't matter. This is all the same rule. And figure out how it moves. Well, P, as you can see here, it goes left 4 spaces, and it goes up 1 space. So that's 4 units left, 1 unit up. That means subtract 4 from X and add 1 to Y, because left is subtract and up is add. Down is subtract, right is add. So your rule would just be XY becomes X minus 4, Y plus 1. That's all there is to the rule. You're just telling what happened. How did this point go from here to there? What did you do? So now we're going to do graph quadrilateral ABCD. The vertices are A, negative 1, 2, B, negative 1, 5, C, 4, 6, and D, 4, 2. And you're going to graph its image after translation of X plus 3 and Y minus 1. So first, graph the pre-image, ABCD. Looks like that. Now I'm going to apply the rule. The rule says X plus 3, Y minus 1. Well, X plus 3 means move right 3 spaces. Y minus 1 means move down 1 space. So for each point, you move right 3 and down 1 and put your new point there. So for A, if it's at negative 1, 2, A prime would become 2, comma 1. Add 3 to X, subtract 1 from Y. B is at negative 1, 5, so add 3 to X, get 2. Subtract 1 from Y, get 4. C is at 4, 6, so that becomes 7, 5. D is at 4, 2, so that becomes 7, 1. Then you graph your new points. and connect them. So there is your image and pre-image. You just leave them both in the same graph. All right, so for this one here, it says write a rule to translate triangle P prime, Q prime, R prime back to triangle PQR. In this case, we're actually going backwards. We're going to start with the prime, which is reverse what you usually do. So to write your rule, you would go x plus y, arrow. Now you have your x's, so start at, say, P. So from P prime over to P. 1, 2, 3, 4 to the right, 1 down. 4 to the right means x plus 4. 1 down means y minus 1. And you're done. If you're going to graph a new triangle, apply the rules. So x plus 1, y plus 2. So r prime would be 3 comma 4. S prime would be 6 comma 4. And t prime would be 4 comma 7. I'm not going to graph those right now because I don't have the space for that, but you know how to graph points at this point. All right, so these are called rigid motions. Rigid motion just means that your transformation changes nothing. All your lengths are the same. All your angle measurements are the same. Those are rigid motions. Translation is a rigid motion because nothing has changed, just the location on the graph. And you might see this fancy word here, isometry. That's another word for rigid motions, isometry. You sound real smart saying it too. Or isometric, we use that word sometimes too. So again, these just map lines to lines, rays to rays, and segments to segments. So you got a postulate right here that says a translation is a rigid motion. And there's define what that means. It means the side lengths are all the same, angles are the same, nothing has changed except the location on the graph. Now, it is possible to combine transformations together into what's called a composition of transformations. Sounds terrifying, super easy. Your theorem here says the composition of two or more rigid motions is still a rigid motion. That just means that no matter how many times you do it, it's still the same shape and size. Nothing has changed about it, just location. So this composition here, we have segment RS that has endpoints R negative 8, 5 and S negative 6, 8. Which looks like that. Now, there's different translations happening here. You have one translation that says xy is x plus 5 and y minus 2, and a second one that says x minus 4 and y minus 2. So the first one, we're going to do that first. So we're going to translate RS 5 right and 2 down. Those go right there. R prime and S prime. R prime is at negative 3, 3. S prime is at negative 1, 6. Then connect the dots. Now, the second translation, we'll change that one, R prime, S prime, 4 units left and 2 units down. So 4 left, 2 down, new points, connect the dots. That is R double prime, S double prime. You can't quite see that. It looks like this. Has 2 markings. That's double prime. That's how you say it, double prime. And those are your new endpoints. So here you have a real life example. You're using floor tiles to learn a new dance move. Not sure why you would do that, but we'll go with it. So you have a starting point in your tiles. You move 1 tile right and 3 tiles down. Then you move 2 tiles left and 1 tile up. They want us to rewrite this as a single translation. So not two steps, just one. This is not that complicated. You have two translations. We're going to write them as a single translation. So after the first one, you'd be at x plus 1, y minus 3, right? Because one tile right, 3 tiles down, plus 1 minus 3. Now it says move 2 tiles left and 1 tile up. So that would be subtracting 2 from what you had in the x's, x plus 1, and adding 1 to the y. So y minus 3 plus 1. That gives you a final translation of a double prime is x minus 1, y minus 2. And that's all that is. And you can even do that without doing all this stuff right here. So 1 tile right is positive 1. 3 tiles down is negative 3. 2 tiles left is negative 2. 1 up is positive 1. If you add those, you get negative 1 and minus 2. So that's your x, that's your y. So x minus 1, y minus 2. So you could do all this, like translate first, get a new rule, do it again, get a second rule, or you can just apply the rules together to get your final answer, whichever one you prefer. That means your final position is 1 tile left and 2 tiles down from where you started. Okay, so I'm not going to graph here, but we are going to find the new point. So if I'm at T 1, 2, I have two translations. I need to find a new location. So minus 2 and minus 4, that's x minus 6. Minus 3 and plus 5 is y plus 2. Apply those rules to your points. So t prime, 1 minus 6 is negative 5. Y plus 2 is 4. U prime, 4 minus 6 is negative 2. 6 plus 2 is 8. And you graph your points. So same idea here. Combine the rules. So x minus 3, y minus 3. Take your points. V prime, x minus 3, negative 9. Y minus 3, negative 7. W prime, negative 3 minus 3, negative 6. 1 minus 3, negative 2.